We have this anatomy of the ear. Okay, this is obviously the outer ear is missing. We have essentially the middle ear and the inner ear. So this is your eardrum, the bones conducting the mechanical sound activation of the eardrum to the cochlea. And then you have the cochlea, you have the vestibular apparatus and the cochlear nerve. Now, yeah, this model is available on our website. We didn't make it. It was a model from about 10 years ago. Just trying to use it. Yeah, the rendering is not great. Okay, no, we did something wrong. The text, the label, the text, the mask JPEG file is for overlaying on top of the base of the 3D model, that base plane. So that's meant to be text overlaid on top of it. Yeah, we need the text visible. Yeah, we'll see. Have quite a few things are not correct.
I understand now. The text_mask.jpg should be applied as an overlay to the base/foundation plane of the ear model rather than creating a separate test plane. Let me fix this. Model loader.js.
There's a text mask that looks like this that meant to go over the base. Show you the location, the physiological location, directions of where, this thing is located in the body and its orientation. And we actually don't need the base plane, the base plate. Yeah, we'll have a toggle button for it. That's a good idea. Very nice idea. This is, by the way, Claude 3.7 Sonnet thinking model. So that's probably why it's taking quite some time. Made 14 changes. Obviously, with just SPA vibe coding instructions, we're just gonna accept them all. Show text label. That doesn't work. Click console. Where did you place the text label? I have no idea. Text label, that specific text label meant to be over that base plane. So I don't know what it should do. Yeah, well, there's a lot of things that can be improved. Yeah, the model is not it's quite a lot of detail in this bit. So it's meant to be, yeah, 3 bones. The labeling is incorrect. Okay, so we have edits. Okay, should we just accept them all? It's always stuffing up something in the texture utilities. Yeah, after you made the changes, again, the texture utilities JavaScript is broken. Yeah, vibe coding. It did pretty well to begin with. I don't know, it's the Claude 3.7 Sonnet thinking model. It's taking some time. Yeah, I was able to break the very long JavaScript into separate parts. So that was nice. Yeah, it's what it looks like at the moment. We have yeah, all this JavaScript. So it's essentially broke a very large JavaScript into different parts, which it did pretty well. But then we're trying to fix the rendering. The labels are not correct. The cochlear is not labeled. Other parts are mislabeled. Yeah, and yes, somehow the rendering of the auditory nerve is not correct as well. That bit there meant to be here. So I'm not sure how to correct it, and not even sure how to explain it to the bot. Yeah, it will be a bit of a lost cause. It feels like we're gonna spend like too much time on it. Yeah, it seemed to understand. I guess we're pushing the model, and this is the best we've got. 3.7 Sonnet by Anthropic Claudette, but it's still struggling. Let's try, I don't know, Gemini. Can you quickly, in continuous text, don't include any code in your response, explain the web application and also indicate any potential issues with the rendering, like the labels and the textures.
The web application visualizes a 3D model of the inner ear. sourced from Sketchfab. It uses 3.js for rendering and includes features like interactive controls, anatomical labels, and multiple material options. Potential improvements include enhancing lighting, adding cutaway views, optimizing the model for better performance, and supporting the GLTF format. There might be issues with texture application or label positioning, which the application attempts to address through texture matching and label distance adjustments. The application preloads a text mask texture and falls back to an FBX model if OBJ loading fails.
What's that? What on earth? Something wrong? Yeah, the label distance doesn't do anything, and it doesn't actually know how to render. Which one meant to be better, O1 or O3 mini? Can you actually go through the files and write the list of which label, how many items, how many, like in the models, how many parts do we have to the models, and label each one. That was a bad prompt, wasn't it? But would O1 be able to handle it? Probably not.
There are 7 primary anatomical labels referenced in the code: CNVII_vestibular, Cochlear_N, facial_nerve, incus, malleus, stapes, and tympanic_membrane, with an additional text label for the mask overlay. The texture directory contains 18 files corresponding to these parts. The main 3D model is anatomy_of_the_inner_sketchfab_upload_01.obj, with ears.fbx as fallback. Each labeled part can have diffuse/albedo, bump, or transparency textures, which the label manager uses for annotations.
Okay, forget the fallback. Can you check the code and just text only explain in the chat if the textures are assigned correctly and if the labels are correct? Can you figure it out and explain?
It looks like the CNVII_vestibular and Cochlear_N textures are consistently named and presumably assigned correctly. However, facial_nerve_bum appears incomplete or misspelled, suggesting a mismatch with any code references to a facial nerve texture. The labels themselves are correct for the vestibular and cochlear nerves, but you may need to fix the facial nerve texture file name to match its corresponding label in the code.
Wait, did it mention? Sorry, can you repeat that? How many parts do we have to the 3D model? How many separate parts do we have?
There are 7 separate parts: CNVII_vestibular, Cochlear_N, facial_nerve, incus, malleus, stapes, and tympanic_membrane.
Wait, this is weird. The cochlear nerve should be separate to cochlea. Where are you getting this list from? Is it just from the textures names? Can you get anything from the 3D object file itself?
From what's visible, the labels and textures come directly from code references and file names. It doesn't appear there's a distinct cochlea label in the same naming pattern, so Cochlear_N might serve for both the cochlear nerve and cochlea. Without examining the actual OBJ file content, e.g., material or group names, there's no clear indication if the cochlea itself is a separate geometry.
Okay, I shared all the files. Can you double check?
The texture file names look consistent except for facial_nerve_bum, which seems incomplete or missing an extension like .jpg compared to the other entries.
Sorry, I didn't get it. So the object, the 3D object, doesn't have names and separate parts to the model, separate components to the model with names or not?
Based on the provided files, there's no clear indication that the OBJ itself has distinct named parts. The code and textures reference separate anatomical features, but the actual 3D file appears to be a single mesh without specific group or part names.
I'm not sure you had the file before. Now I shared the object file. Can you check how do you parse this thing? Can we actually display if there's any elements to it, or is it a single mesh, or are those multiple components?
You can parse the OBJ file by scanning for lines starting with O or G to find named objects or groups. If none are present, then it's likely a single mesh with no distinct subobjects. Based on a quick check, there are no separate O or G sections here, so the model appears to be a single mesh.
Okay, that's not fun. So essentially all this thing is a single object, which is yeah, it's not great. Well, first because we'll have trouble labeling it or doing anything else interesting with it, like animating it and stuff. Any idea how would you break the single mesh into separate components? Is that possible?
You can import the OBJ into a 3D editing tool like Blender, manually identify the regions you need, and separate them into individual objects by selecting and splitting the mesh. Essentially, you segment geometry in the editor to create multiple sub-objects, which you can then export as separate meshes or group them with specific names.
Okay, and the Blender can be automated using Python, is that correct?
Yes. Blender's Python API allows you to script importing the OBJ, separating geometry, and exporting the parts automatically.
Actually, any idea if I can do it without Blender?
You can use Python libraries like pysimp or Trimesh to load the mesh data, identify vertices/polygons by region, and then separate or isolate them into different meshes without relying on Blender's UI.
Okay, that actually sounds more like it. Can you draft some Python code for me? Yeah, I want to load this mesh, try and breaking it into separate components, because we're not getting... Wait, how?
Plan. Load the OBJ. Split into connected submeshes. Export each submesh separately. Import Trimesh. Hashtag load the mesh. Mesh equals...
Okay, got it. No, wait a second. Wait a second. Back to what we were doing before with the current code. How was the rendering done? How were the textures applied to different parts? This makes sense.
The code loads the entire OBJ via 3.js, e.g., using the OBJ loader or a similar loader, then relies on a predefined mapping of part labels to material definitions. Each material references diffuse/albedo, bump, and transparency.
I mean, in the current project, how are if we only have one mesh for the whole model, how are the individual textures being applied to different parts of the model?
The code attempts to match each subobject by name and apply a corresponding texture. However, since the model is just one mesh with no named subobjects, the same material/texture set gets applied to the entire geometry rather than distinct parts.
That's not actually correct, because the code is somehow able to apply the different texture image files onto different parts of the mesh. So if it's a single mesh, how does it do that?
It finds multiple child meshes, each with a name, rather than one single mesh. The loader and texture utilities traverse these child meshes, match their names, e.g., facial_nerve, to known texture sets, and apply a different material/texture to each.
Again, just to confirm, so the object is a single mesh, but it has what is it called? The daughter sub meshes, child meshes. So we can separate the code, and each child mesh has its own name. Is that correct? So why currently the labeling is not right and the rendering of the texture is incorrect? Okay, going in circles now.
Yes, each child mesh has a separate name under the main object. The labeling logic and texture application both rely on matching known part names, so if mesh names don't match the expected patterns, labels and textures end up incorrect.
Okay, in the code or in the chat, can we extract all the names of all the child meshes?
Plan. Load the OBJ with 3.js. In the loader's onload callback, traverse the loaded object. If a child is a mesh, print its name. Import asterisk as 3 from 3.
Okay, assuming this is JavaScript, does it go into a separate file, or do we modify one of the existing files to display that information?
You can add a snippet to an existing file, like main.js, if it logically fits there, or you can create a dedicated script file if it's a more distinct feature. Typically, if it's just displaying text, integrating into an existing UI code block is simpler, but a separate JS file is better if you need a more structured approach.
Okay, I guess logically it should go into the label manager. Oh, wait, no. Wait a sec. No, can we actually have it as a standalone file? Let's try O3 mini. Okay, can we actually write the standalone instructions for another developer to add that check as a separate JavaScript file and update the main.js and the index.html to actually use that file? So we essentially want to display all the names for all the sub children, for all the children of the mesh of the 3D model.
Instructions. Create a new file named meshinspector.js in the js/folder. This file will export a function that traverses the loaded 3D model and logs the names of all its child submeshes. In this file, write code that checks every descendant of the model object using object.traverse and, if it is a mesh, logs its name. In main.js, after the model is loaded, for example in the OBJ loader onload callback, call the inspection function from meshinspector.js to display all submesh names. Finally, update index.html to include the new meshinspector.js script before main.js so that it's available when main.js runs.
Okay, this is a perfect prompt. Let's copy it. Go to editor. We have reached the maximum number of files that can be added to the working set. 20, because there were 31 files. 21 files are excluded from the working set. Okay. We do need the object. The model is loading correctly. Orbit control, no. C, no. 3GS, no. Not modifying that. Yeah, that's we only need the 6 files, and then we have that prompt that O1 wrote, and we are using 3.7 Sonnet thinking model. We wanted to take its time, need to get it correctly. Let's see what it does. Still thinking about it. Well, yeah, it's a thinking model, so it's a thinking model. What's the difference between a thinking model and a regular LLM model? Is it just is the thinking model just sending more prompts back and forth automatically? So it's essentially using the same original LLM model, but just doing multiprompting back and forth, or is it a different model altogether?
A thinking model generally refers to a system that can break down complex tasks into smaller steps and tackle them sequentially. It may involve multiprompting, where it repeatedly asks itself questions or takes intermediate steps to solve a problem,
Can you be more
almost like a human would.
Can you be more specific and cut out the fluff?
Sure. A thinking model often means a system that breaks tasks into smaller steps, sometimes using multiple prompts to think through a problem. A regular LLM typically responds in one go without breaking it down like that.
Yes, so essentially the thinking model using the same LLM, but then just prompting it several times, or is it a different model altogether?
It's usually the same underlying LLM, but it prompts itself multiple times or in different ways to solve a problem more effectively.
Okay, do you know much about the difference between using ChatGPT from the website and as compared to from within Visual Studio Code? Do you get access to the same models, or the models are different?
The underlying model is typically the same, but the experience can differ. Using ChatGPT from the website usually gives you a user-friendly interface with rich features. In Visual Studio Code, it's more about integrating the model into your development workflow, so the focus is on coding assistance. The models themselves are the same, but the context and use cases vary.
Yeah, what do you know about what are the parts of the inner ear?
The inner ear has 3 main parts: the cochlea, which is responsible for hearing, the vestibule, and the semicircular canals, both of which are involved in balance.
And what's connected to the cochlea going to the brain?
The cochlea is connected to the brain via the auditory nerve, also known as the cochlear nerve. This nerve transmits sound information from the cochlea to the brain for processing.
Okay, we have this single mesh 3D model of the middle and inner ear.
That's great. With a 3D model of the middle and inner ear, you can visualize how the different parts, like the cochlea and the auditory nerve, fit together and function.
Now already displaying the model, but we're trying to render it correctly. Eventually, yes, we wanna do like game animation, simulation, potentially include sounds and everything. Currently, we're having a problem that the model is a single mesh, but supposedly it has children components.
If the model is a single mesh but should have child components, you might need to check the original 3D file to ensure it's properly structured. If it was exported or imported incorrectly, the hierarchy might be lost. You can also try separating the components in a 3D software like Blender, then re-importing. That way, each part can be animated or interacted with separately.
Also, we do have the children. We have 9 children in a subarray, and they do have names and everything. So we should be able to use that.
Great. If the children components are in a subarray and have distinct names, you can access and manipulate them individually. This should allow you to animate or add interactions to each part separately, making your simulation more dynamic and accurate. It sounds like you're on the right track.
Oh yeah, thanks for the encouragement.
You're welcome. I'm glad to help. Good luck with your project.
But we're still having trouble.
If you're still having trouble, it might help to check the 3D model structure in your modeling software. Look for any hidden objects or nested meshes. Also, ensure the export settings maintain the hierarchy. If needed, you can manually separate components and re-import them.
This is the structure of the object. It supposedly has this 9 children components. So if you can use this structure and extract the name and all the relevant information, we want to be using it for rendering and labeling a model. So we want to essentially have here nine different labels that are placed correctly, and we want to use the correct image for the texture.
I'll create a specialized enhancement for the inspector.js file that provides detailed analysis of the ear model based on the output you provided. inspector.js. I'll enhance the existing file with functions specifically designed to analyze ear anatomy meshes.
Okay, I can do it quietly. Eventually this stuff will appear on bionicchaos.com. Go check it out. The link should be available pretty much everywhere. I'm still trying to fix the rendering of this model. It has 9 separate components in it. And we have Claude 3.7 Sonnet thinking model doing the changes for us. Seem to have done quite a bit. And why are we creating only 4 labels? Those are bad names. That's why it cannot choose the texture file. And wait a sec. So we have the model. Okay, we have 9 children. We have the geometry. We have the name of the parent. Why do we have only 4 labels? We have 9. Supposedly we have 9 elements. 9 children to the mesh. Can you guess which one is Cochlear and the auditory nerve?
Based on the model structure you've shown, I can help identify which meshes correspond to the cochlea and auditory nerve, and enhance the mesh inspector to better recognize all 9 parts. Let's create a targeted enhancement for the inspector.js file to better identify these specific ear components. inspector.js.
It seems to know what it's doing. Just let it do its job. Yeah, we had the 3.7 Sonnet updating the code. We're doing vibe coding, so we're just gonna accept. And let's clear the console. How many labels do we... No, we still have the 4 labels. Okay, we want all the 9 labels to be there. Like if you don't know what they are, just make a guess or something. But then the information should be in the object 3D file. Let's try on 1. Anyhow, we need the labels and the rendering or the texture rendering to be fixed, to be correctly assigned. You should have all the information. Or 1.
Here's a concise way to ensure all 9 meshes receive a label and the texture assignment logic is more robust. Update label manager.js to include all 9 part names in its known mappings.
Yeah, this looks a bit better. We have all the labels and the placement of the Cochlear and vestibular supporting structure. I'm not sure about that. And this meant to be an auditory nerve, not cochlear nerve. Anyway, we will continue this next time. Hopefully it gets better. Everything we do eventually appears on our website. Go check it out. There is a lot of interesting stuff. We do have a Cochlear simulator from a while back that's actually using your microphone to simulate how different electrodes along the cochlear array will get activated. So you can choose the number of electrodes, do some filtering. So do go check it out. And I'll see you next time. Bye.